So, hello everyone. This is Tulio, and this is gonna be the first part of a series that I intend to make. And the idea here is just simply to get some thoughts and to take some projects that were in my head, and I can just share them. I can explore some new stuff, and also experiment a bit and enjoy some feedbacks and also new ideas. So I often delve a bit into the data engineering, data science roles. So here I was thinking on trying to do a big project, but doing it step by step. And all these steps will be taken, well, each one of part small videos, something light, something easy, and something chill, also something cooperative. I'm gonna do something. I'm gonna do a bit of research at the same time, documentation, and to feel like we're building this together. And so the idea today is something I've been wanting to build. So we're gonna be working a bit with cloud, and so the idea here is to allow us to grab some data, manage this extraction of data, then clean it, trying to understand which one of the best architectures may fit that role. We are gonna think here on some cases. That's the idea, and try to imagine a possible business scenario. So we can actually go from mining the data, storing the raw data, then pulling this raw data into cleaner tables. I'm not gonna use gold tables and this sort, but make it refined tables, and and yeah, and then allow us to go to a more analytical part and do the extraction, raw processing, and then BI visualization, and properly where will be the business intelligence, right? So we're gonna start. So we're gonna start drawing a layout of what is going to be done and what is the idea here. So let's go to the drawboard. Of course, it's gonna be in dark mode. Love it. So, all right, this is my Windows. This is my Ubuntu, and I'm very proud of it because it was some stuff was really hard set up, but now I was doing dual boot with my Windows just because I like to play some stuff sometimes. And yeah, however, now I managed to put Steam into my Ubuntu. Now I'm just giving up on Windows. So yeah, this is my setup. So let's finally start. So the idea here, I wanted to use a project based on a bit of a resource I found ahead. So some time ago, I used and I have, and let me just add this as we talk. I had access to the Foursquare API, and the Foursquare API. So I have some credits there, and I say like, okay, let's try to get some good and reliable data, and then we draw our model from there. So today we're gonna draw the first part, the data mining. So on the documentation of Foursquare, and so we allow us. So let's suppose we have here. I'm gonna add this map as it would be the world. Let's just put it like that, and let's put like a bit. Yeah, this is okay. Okay, this is the world map. So we have the world map here. All right. So Foursquare allows us to make API calls, and these API calls can be designated by a point, latitude and longitude, and radius. And you can also define the polygons that this API will call. So Foursquare gives us an API. Let's just put everything here. Gives us many APIs, so we're just gonna represent one of them here. And we have get places. This tip doesn't make sense here. I'll just put none. All right. Okay, so we have get places, and get places. Let's just put some of the inputs would be there. Parameters. It can be so basically. We have let let, oh, sorry, my fingers are broken. Long. We have radius. So some of these are mandatory, but I don't want to get into that now. Okay, let's make it shorter. And oh, I don't like the way this. Okay, this looks pretty enough. All right, just this and this. They come right over there. Oh, yo. Technology, eh? Okay. So, we got Foursquare, the parameters, get places. All right. So here we allowed for each one of these calls. So we add the parameters lat, long, and then we can go there and extract all the places that are registered inside Foursquare database, and then we have lots of parameters. I would say public, but it's not public. And here, so Foursquare, and here here is what I want to say. It's important. So each one of the API calls has a maximum of 50. Well, there are 5 here. 50 results. So here we get to results. Yeah, but let's just put 50 per request. And so what happens if I add, let's suppose my target, so I want to extract data from this. Let's also go, so the idea here, I want to compare some settings between Belgium and Portugal, and let's suppose this is our target, right? Then let's make them red, because red are targets. Yeah, I guess that's good. And if we add, let's suppose our request, we have 2 methods. We can put a latitude and a longitude, and this would be imagine just having a dot, very small dot. Damn. Okay, let's make it small, but not as small. Okay, this is a dot with a radius. So let's suppose I make this API request. So let's suppose here there are 500 places. Foursquare API will return me 50 sorted by a parameter that I can use. Again, we have lots of parameters that I did not list here, and we're gonna take the 50 first. And what about the other 450? So we need to make lots of more API requests, and we need to allow us to make request 1 here, then we go request 2 here, and then request 2 here, so we can ensure that we mapped the whole area we're looking for, right? And okay, all right. Or we have method 2. Let me just put my helping boy here. And method 2 is, this is gonna be also, yeah, this cannot be, let's do black as the other one. We can also draw many polygons. And I say, I give to my request, I give the lat long, but now I'm gonna give 4 lat longs, and these lat longs are gonna represent my northwest, northwest, northeast, southeast, southwest points, and then I draw a polygon. Here I can ensure that I make polygons small enough to return a number smaller or equal than 50. Then we can do an iteration. Well, it disappeared. We can do an iteration of, I do API request call, grab data, send data to somewhere, do this, and I go in an iteration trying to map all my target, and then I can ensure that this rectangle is big enough to fit 50 request results. Is it gonna be perfect? No, it's not gonna be perfect, but that's the method I'm gonna follow here today. So yeah, we have the idea. All right, what we're gonna do in this first part? We are gonna have a Python script, and that's what I want to build here. We're gonna have a Python script. So well, here's Foursquare there. Let's do, yeah, this, I'm gonna need this eventually. Let me just put them here. A pretty cylinder. And we're gonna have, I want something that can represent, give an idea of a computation agent. but let's put a rectangle. Okay, so this is gonna be a Python client. All right. So okay. So the idea is gonna be we're gonna have a Python. This Python is gonna iterate over these rectangles, and this Python is going to use our request to get the places. Yeah, I want to make a smaller dot. Yeah. Just make it up. No, it's still ugly. But let me just kill the tip. Yeah, that's all right. So we're going to use our Python client. It is going to use the Foursquare API, and okay, we're gonna get the places. Okay, what we do then? All right, we're gonna extract the result of this data. Is gonna go to so since I want to use and also showcase some cloud tools, we're gonna use my cloud, which is Google Cloud. Yeah, let's not. I'm gonna put Google Cloud here. I'm gonna put here big. We're gonna put here Google Storage because not BigQuery yet, and we'll go to that. So, okay, the Python client gets the places. So the tip here, it's actually on the other direction. Tip is there because, well, yeah. So, and we take a file and send it here. Guys, I'm not worried into making it super pretty. I want to make it understandable and not messy. And so we put this here. Okay. And then we send it to Google Storage. And we're gonna do this iteratively in iterations. And so I'm gonna put here to give an idea of n. So we're doing that n times. I don't know how much n is gonna be. Alright. Okay, so and after we do this, okay, so the logic is pretty clear. Then after we have it in Google Storage, we're gonna roadmap it on step by step. We don't need to worry now. Let's suppose we were just given the mission, hey, I want let's also think of here as a business scenario. So Tulio, I love cookie stores. So I'm really thinking on opening a cookie store, and I'm super flexible. So I'm thinking, well, I can build it in Antwerp in Belgium, and I can build it in Portugal, in Lisbon. I can build it also in Ghent. I can build it in Brussels. You got the idea. How do I have intelligence, and how do I know who I'm going to compete, where am I going to compete? How do I get a bit of leverage? How to extract a bit of intelligence? So here we're going to extract the places, and then I'm going to add some more seasoning, something that we can play a bit more to get up to this intelligence and having some insights. And so yeah, first things, we're gonna get the mission of today. We're gonna make a way for this Python client to go here, and I already have some stuff built up, so don't worry, don't die of boredom. And okay, I hope the idea is clear here. We're gonna go there to the code, and so I already started a bit of a code, and I wanted to present it. Let me just make it okay. We got big eyes. All right. So here, spoilers. Okay. So what is going to be the idea here? The idea is we're gonna have a function. All right. And so I'm gonna run. This is not done yet. I'm gonna build something here. Just want to make a bit so we can start and also have a bit of something so we don't take too much here. All right. So okay, right. So first I'm gonna use some famous libraries from Python, and so here I'm gonna use OS. I'm gonna use Folion. Folion is a library that works with maps. even though folder is not here, I can delete it. I then add it to the tests. .env is gonna be good. .env is we're gonna use this file, which I'm not gonna open, because there's like where it's a good practice to hide our more sensible data. So here is just the name of my repository in Google Cloud, the name of my project. Not super confidential, but still. So we summon from inside .env, we pull this function, we call this function, then this function extracts and takes all this and dumps inside the environment from that session. And then I use OS just to grab these variables. Here, this is something I'm getting addicted to, but I learned it while using Java. It's to do this. I know it sounds silly. It's not required, so I can just do this and it's still alright. However, for my eyes and for my functions, I feel like it's easy for me to understand what kind of object we're working with. So, we go. Alright, so, okay. And here I did an assertion, but here's nothing is too important first. So, let's go to the first part, which is here. How are we going to do the requests? So the requests are going to be done like this. So whoa, spoiler alert. Yeah, here in API. So I'm trying to do a bit of a pretty distribution of the code, so we don't get a monolith, but we try to make lots of different modules. Yeah, so this is what I built. Let's check it. This is a function, and this function gets a path to be saved. So it's gonna extract the places from the API, saved somewhere. It's gonna use the API key. It's gonna return a polygon, and this polygon is a list of tuples of floats. So it's basically a list of latitudes and longitudes. So longitude and latitude we're gonna treat as a tuple. So they are, imagine a container with two little boxes. And so we have a tuple and we have a list of tuples, okay? Simple. And this polygon is the input. So here we're saying, remember the approach that we draw here? This square is gonna be there, and it's gonna be this this variable. Categories, it's a flavor, it's an extra parameter, but I'm not really using it. So yeah, it's here, and it's not a mandatory variable because we initialize it as an empty list. Okay. Here, documentation. Nice, love documentation. So we go here. Yes, here is this is gonna be the big thing. Here is where we can take a look at what we're doing and what we can do. What I'm talking about is, so we are going to do, so we have here a query that can be done. We have LL, which is the latitude and longitude compiled together. We have radius. Okay. The approach we are doing is exactly this approach. All right. So we're gonna send here the 4 coordinate pairs. All right. And then yeah, then let me just do like 1, 2, 3, 4, 5. And here it does prep the this. Oh, it didn't add. Oh no, it probably did. Yeah. So here you see it adds to the API, and this is already in a nice way. But we're gonna use Python request, so it changes a bit how we approach it. I think it's more elegant. And okay, this is what we're gonna use. Going back. Okay, so base URL. I'm gonna define it here because it's something static. Oh, I committed a mistake here. Yeah, I committed some mistakes from my perspective here. We wanna want a dictionary. Okay, so we're gonna use this as a base URL, and this is the layout from the header. And I'm gonna inject my API key here as the authorization bearer. And Oh, how am I getting the API key? Yes, the API key is gonna be, so let's go. I have also some tests here, and these are the ones I'm ready to show today. And get places, get places, get places, we call it here. So the Foursquare key comes from my environment. So this is a good practice, or you can also do something like this. So in Linux, I don't know if some of you are familiar. In Linux, we have something called bash rc, and bash rc is basically a script that runs every time a terminal opens, and it's oversimplifying. And so I injected inside bash rc, and bash rc it's gonna be here. So it's gonna be in my home. Let's just put minus lah, ls lah. It's in my home. So yeah, I guess I can do this already. And but then I wanna, okay, yes. Okay, so what we have seen here is that we have the bash rc. I'm not gonna open because there's also some particularities of my PC, but we have it here. So I injected here two important variables. First, the Foursquare API, and the other one we're gonna get there, but is the Google credential. All right. So yeah, not needed anymore. We get it. Right. We go here. So we add the parameters we want. I have a function that is going to format the polygon because the polygon accepts a very specific format, which must be sent as a string. So my function here. So if you see, I just iterate over my numpy float. That's the result of my polygons, and yeah, and I return them joined by this tilde. All right. Okay. And so I do my request. I send a basic URL. I send my header with my authorization, my parameters. Then, if this status code is 200, what means like all good, we save it. And where do we save it? Well, that's to be seen. But I'm adding this inside this TMP. You say? All right. So, first things first. Now we already know. Yeah. So we can go to the test. Okay, so first, you remember when I said that we wanted to make many requests with smaller polygons that are, let's go back to the diagram. So we want our polygons to be subsections of this polygon. So we want them to be, let me do like this, so it seems like they fit. We want to do something like this. Damn. I'm gonna do this. Oh, okay. Yeah. All right. Let's think. We want lots of these guys, like bloop bloop bloop, and each bloop it's one streak of the API. So we get bloop 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 populated. So we need then something that iterates, returning me a bounding box for the polygons inside my big polygon. So what did I think? We're gonna build a class in Python that is a polygon iterator. So let's show it how this works. So here we have my class. It's a rectangle polygon iterator, super fancy. And all right. And well, basically I wrote here. So it's an iterator that uses smaller rectangles as the 4 points required by the API. And then I ensure that I divide it on a specific number of grids. So let's see if I have a grid like this, and I say I want to divide it in 4. So 4 is my input, and I divide it by equal spaced rectangles. Sounds nice. So we get self, obviously, and in it we get the rectangle points, and this rectangle is this red one. Then this was nice. And the number of polygons we want to split. Here there's a bit like I made something that only works nicely when you use numbers that are, you can take a square out of them, the square root, sorry. Yeah, I forgot a word in English. Okay. So, well, this is the basic asset. If that's not int, well, that's not int. All right, and then I need everything. here is the important part. The iterator should have the iter function, and this function tells us how something is going to be iterated over it, and this iterates yielding the points, and these points are linear equal space from each one of them, so we make pretty boundary boxes. How does this work? Let's see, tests. Let's call my terminal here, and well, I'm already doing something by default, which is I go here, I love doing it, and so run commands and select Python interpreter. So here I already have the environment open, but I want to use the debugger from VS Code, which is pretty nice. So I'm gonna ask which Python I'm using, and obviously you say it's the Python that I'm using here. So home, Tulio, repos, data ang, la la la, and I want to add this to the interpreter here. Show and run commands, select interpreter, and path blame. Boom. And now I can do this. So from my tests, no, actually I have a test runner here on the root level, which is better because my terminal is gonna be launched exactly on the root level here. And I don't want to test the polygon iterator, but the city bounding boxes. So this is already using map. Oh yeah, I forgot something important. So here I'm defining a YAML, and this I'm not gonna need anymore. So we're gonna define here on a way that we can expand this easily. And I hate that this doesn't have big L. So we just define, I went to the map, I drew a random polygon that covers approximate the area from Antwerpen and Lisbon. And so here you see we can expand easily for other cities. You can just copy here, and we can have like we can have like Paris. Yeah, of course the letters would change, but 2 is enough for this first part. And so I'm gonna go here over my test runner, and okay, so this I don't want to run yet in this test. I don't want to get places. We just want to see the bounding boxes. And here, the bounding box is nice and it's pretty because I use Folion, and I just want to tell a bit how the Folion works. It's pretty simple, and I think everyone should work with it because it's also pretty and you can spread data really nicely. And so I extract the configuration file, and it turns into a dictionary from the configs YAML. I do my practice, like the first city is gonna be the one I center my map at. So first city is also a dictionary that extracts from the configuration, and the center of it is the first coordinate of the rectangle, right? And this, so let's go back to the YAML here. So city, name, rectangle chords. This is all the parameters it has. Okay. So here I initialize my Folion map as M for map, and then so for each one of my cities iterated from my YAML, I want to create my Folion polygon, and it receives the rectangle coordinates by my city. It has a pop-up with the city, easy, random color, fill, opacity, basic, right? And then I add to the map, basic. So here we just drew this big polygon, the red, all right? And now, so inside the city, I also want to draw the mini boxes, as I call them, and each poly, it's gonna iterate in my rectangle polygon iterator, which is that class we talked just a bit. And the rectangle points here, it's gonna receive what we get in the YAML. And here I'm divided by 64 polygons, right? Okay, so Folion polygons, la 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 la. Locations are the poly, that's the mini boxes, this little fella. And the pop-up, I'm just ensuring it's the polygon, because this I guess is gonna compile to NumPy float. And la la la, I to the map, save to the map. Web browser library everyone has, it's native in Python, and web browser opens a browser where you can interact a bit with your HTML. So with Folion is really nice. I'm talking too much. Let's do it. Just take this off and blue. Let's cross some fingers, no errors. Yes. So this is the idea. So here, well, I have a small bug, which is we don't see the difference in the colors on the foliant, but I don't think that matters. I think this is just a test on the logic. So here is the idea. We're gonna take Antwerp. So I want to target all this big rectangle. This big rectangle is my one here in draw you, and as I draw it, I want to, each one of these polygons is going to be my mini boxes. So one API request, two API requests, three API requests. Is number 64 optimal? No, no, it's not. And so today we're just gonna talk about the layout in the first data mining. Then on the next session, I'm gonna do the optimized version of the data already get into the bucket and then being treated in the bucket, all right? And okay, we did Antwerp, nice, pretty. Now let's travel really far. We travel to Lisbon. Hey, here it is. So yes, the same logic, and we see that the polygon rectangle iterator is working nicely. I think it's good. So here we are here right now, second line, and we're going to. Oh yeah, I don't know if I made it clear. No, I didn't. But I'm going to be living in Antwerp, and well, we are me and my partner, we are leaving. She left already, and yeah, we're gonna leave here. Where are we gonna leave? We're gonna leave around. Yeah, we're gonna leave here in Vilrijk, but I don't think I covered it. But well, this is not final. All right, this works. Now what we're gonna do? Okay, we ran the code. Okay, so pretty. And now I want to test. Let's here in the get places. The get places is my test function. So how do I like to develop? I create always the mini test, and the test is obviously tested the mini modules. And once they are good, then they get into production. What is going to be production here? Location extraction. I'm not working too much in this function because, well, the tests are still being done. So let's focus on the test, and eventually I just push the layouts from the test to here, right? And go to test. Okay, our map, I don't think we need it anymore. I don't want it, sorry. And yeah, here is already in git ignore, so we don't need to be afraid to lose it. Okay. So in the get places, we extracted stuff from the polygon. Yada. Here I put in lower. So I always gonna iterate in my rectangle polygon iterator. So here I'm going to make smaller polygons so we can have. Oh yeah, and there is also it's not a flaw, but it's not something too big. Inside rectangle polygon iterated, sometimes the number of polygons aren't exactly like this because I do a bit of a rounding up inside the function, and yeah, it may be plus one, minus one dimension. So I'm going to do, let's do 16. 16 is good. So we don't make that much API request because, well, I had some money for a project I did back in the past in Foursquare. That's why I think I'm using this again. So here I do my file path, and my file path is going to be simple. So I'm iterating here. It's temporary, the name of the city, and this gets poly, and this gets the index of the poly. Here I'm doing some basic poly indexing. Poly gets one more here. First, I added the break because I just wanted one request, but now I don't. Now I want 16. Hopefully 16. And now I just want to put a logger info here, and this actually let's do a warning. And iteration number, this we gotta do F here. Iteration number poly IDX. So here we're gonna start with 1 because I add the logger after the 0 gets a 1. Iteration number, yeah, that's enough. Logger, I didn't declare my logger. Yes. I recall that in some functions here I did my logging. So here. Let me also take this to test. Let's put here. All right, now, oh yeah, but now I'm gonna change it to logo. I don't know, I forgot. Let me just check here. Import login or as log. And now log.info. Can I do this exactly directly? La la la. Hey. Yeah, but this is about the login level. Yes. Okay. One is good. We can do logo warning. And okay. So what we want to see now is, so we're gonna get for each one of these polygons we want to store, and we're gonna have it here. So I'm gonna delete these two old fellas, and we're gonna do the test run on. So now we're gonna take the gap places. Actually, I'm gonna do something nice. We're gonna stop. I'm gonna stop here, and then we can debug and pause the debug there. So I'm gonna just run out, and I want to debug. Where is it gonna stop? Yes. Okay, got. So what is the nicest thing here in VS Code is this. I love it. I love being able to pause my code, interact with my variables. So here, look at the center. It's all pretty. The city name, we know we're iterating here. Look at this. Where is it? The first. Yeah, this is all we have for now. And so we got the debug console. All right. As now I want to go here. Right, so we go to step over, step into, step out. We continue. Bang. Okay. So places raw returned. So, oh, did it return? Well, I'm afraid places raw did not return. Let me just run all over, and then. Go on, step over. Okay, we don't need you anymore. Continue. Blame. I'm not checking the terminal. Oh, yes. Oh, yeah. So see, 16, pretty. And now let's see. Oh, yes, this is lovely. Yeah, here's just from 0 to 15. But yes. So here we have a big long ass JSON. So we have Frutoflan. What is this place? This is from, I don't know what this is. We'll find out in the future, because now we just want to extract, and yeah. All right. And guys, the next step is gonna be eventually taking all of this and sending to Google Cloud. But this I'm gonna make on the next video, else this is gonna be too big, too much. And I want to thank for everyone that came here. I hope I get some support, and any ideas, best practices. I'm always hoping to learn a bit more. And that's it. See you after the next one, and then we're gonna send it to the cloud. We're gonna focus more. So this, we did the green part, bling, this part, and now eventually I want to post another section, and then we're gonna navigate a bit more into this pipe here, and then we can actually do some really nice stuff. Bye, and thanks for being with me till here.